factorial symbols, remember that was like kindergarten and you had to count backwards and the factorial symbol was like blast off. So if you had 7 factorial, it would be like 7 times 6 times 5 times 4 times 3 times 2 times 1, blast off, right? So if I gave you 7 factorial, no, it's transferred. Why? It's on this, that's why. Nope, that didn't fix the problem. Oh, no. Whatever. I have to get over it because it transferred to this one too, so this is great. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. We agree? Now, if I gave you 7 factorial over 4 factorial, I would expand the bigger one. So 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And it would be over 4 times 3 times 2 times 1. And then I could cancel these all off, right? Because they would be the same. So instead of writing it out as 4 times 3 times 2 times 1, we could just leave it as 4 factorial. And then cancel the 4 factorials off. So you take the bigger one and expand it and keep the bottom one. So I'm going to keep the 4 factorial down here. The top I'm going to expand to 7 times 6 times 5 times, and what could I just put instead of 4, 3, 2, 1? 4, what? Factorial. We agree? And then I can just cancel them off and not have to write them all out. Do we agree? So if we take the bigger factorial and we reduce it till it gets to the smaller factorial, we can cancel them off. We agree? Okay, what if I give you n factorial? How would that expand? Well, what are we doing to get from 7 to 6 to 5 to 4? What are we doing each time? Down by what? 1 every single time, correct? So if we start at n factorial, we would have n, then we would go down by 1, which would be n minus 1, and then if we subtract 1 from n minus 1, we get n minus 2, and then we would get n minus 3, and then we could put factorial, or we could keep going, n minus 4, n minus 5, but we'll never stop with n, because until we know what n is, we don't know when it gets to 1, right? So we would have to actually keep going and going and going. So we're going to your notes, which is where you're at, right here. Simplify the following expression. Leave the answer in product form. What is product? The answer to. What operation? Product. Multiplication. Yeah. Okay. We have n plus 2 factorial over n factorial. Which one of those is bigger? N plus 2 or n? N plus 2. And the reason why is it's confusing right off the bat which one would be bigger. But if you put a number in for n, you'll see which one's bigger. So if you can put any number in. Say I put 4 in. This would become 6 factorial. That would be 4 factorial. And then that's more obvious that that's actually bigger. Correct? So if you put a number in it, it is a lot easier to tell which one's bigger. So the bigger one is n plus 2. So I'm going to go like this. I'm going to draw it. It's going to probably give me something blue, make me sad. Yep. Cool. Awesome. Great. I like it. It makes me happy. N plus 2 is bigger. So we must expand it. Kind of like it's highlighting it. Look at that. It's not differently. So we have to expand n plus 2 till it matches the bottom. We agree? So I'm going to rewrite the bottom. And look at this. This is the craziest thing. When to use an equal sign or an arrow. Because people don't know. And the randomness equal signs and arrows appear. And profs complain about it all the time. So we are simplifying. If we simplify an expression doesn't have an equal sign in it, right? An equation has an equal sign, an expression does not. So when we are simplifying an expression, it means this is actually equal to the next thing, correct? We cancel some crap off, and that's equal to the next thing. We cancel some crap off, and it's equal to the next thing, yes? So we run equal signs down the left-hand side whenever we're simplifying expressions, because this is actually going to be equal to whatever I do next, yes? And then that's equal to the next thing, and that's equal to the next thing. And if you understand why something is equal, or where you put an equal sign, you will actually do it correctly rather than just guessing where you should put equal signs, right? So I'm taking n plus 2 and I'm going to expand it, and n factorial, I'm rewriting it. So if I just expand this, is this statement not the exact same as that one? Just in a different look, right? So they're equal. That's why you put an equal sign down the left-hand side and run it down. Does that make sense? Do you understand why you're doing something you'll do better? Okay. N plus 2 factorial, we're going to expand it out. So we have n plus 2. What's 1 less than n plus 2? N plus 1. What's 1 less than n plus 1 if I take that 1 off? N. And now it matches the bottom, correct? So I'm going to go n factorial, because it could just keep going. The factorial states that just means that it keeps expanding, expanding. So do you see why I made this one equal to this one? So the exact same thing, just wrote a little different, right? I expanded that top a bit, but it's the exact same thing. We agree? All right. Now I cancel this one off with this one because they match. So I'm left with n plus 2 times n plus 1. Did you know that these slanted lines are just ones? Every time you cancel, that's just a slanted 1, technically. So if I take n plus 2 times n plus 1 times 1, that 1 can just go away, right? Because when you multiply by 1, it does nothing. Here I actually have a 1 in the denominator. Do I need to keep a 1 in the denominator? No. Let me explain why. If I give you 4 over 1, is that equal to 4 if I just drop the 1 off? True statement. That's why the 1 can go away. Did you know that every number actually is a fraction? It's just over 1 if you so choose, right? That's how you make common denominators when you make fractions in junior high. But what about 1/4? Can I get rid of the 1 and say it's equal to 4? No. You guys see that and you're like, absolutely not. That's stupid. But when I give it to you not as like a numerical fraction, and there's a 1 in the top, you guys will cancel it off for days and just get rid of it. Remember that if there's a 1 in the numerator, or you just have a slash line left over in the numerator, you got to keep it, because 1/4 is not equal to 4. That is not a true statement. You have to keep that 1 because it makes it that fraction. Make sense? All right. Let's go back here. So we are working on B. Try it out. We don't need to expand these because it says simplify and then leave. This is the larger number. All right, so we're going to get to n minus 2 is going to stay the same. We have an equal sign running down the left-hand side because this is an expression, and this expression equals the next one. Yes? Make sure you have those equal signs. Very important. Then n minus 1 factorial is n minus 1. Subtract 1 from it, I get n minus 2 factorial. The n minus 2 factorials cancel off, and a lot of people will tell me I'm left with n minus 1. Are you left with n minus 1? No, you're left with 1 over n minus 1. Because this is just a slanted 1, correct? So I'm left with a 1 in the numerator, not 0. I'm left with a 1. And in the bottom, I'm left with n minus 1 times 1, which is just n minus 1. Yeah. Make sense? Okay. Example 2, we have to solve, algebraically solve. Algebraically solve means you have to do some algebra to get an answer. So if you just guessed and checked for n, you put in a 2, then you put in a 3, then you put in a 4, then you put in a 5, 6, 7, whatever, until it gave you 42 in your calculator, that would give you absolutely no marks. That's called guessing and checking, not algebraic. Okay? So we have to do an algebraic process for it. Now this is the key thing. I'm going to tell you guys this right up front. Most of Math 30-1 ends in Math 20-1 or 10. So you do Math 30, and then you end it with a 10 piece of material or an 11. So some people, that's scary because they didn't try hard in 10 or something like that. Shouldn't be scary. But say we do factoring, and we go and I'm going to do it quickly in class because I don't have time to teach you factoring. Like I have 11 units in 16 weeks. And you're like, man, I don't remember factoring at all. Cool. Get past denial, get straight to acceptance, and come in at lunch or scheduled help and say, Mrs. Lepp, I don't know how to factor. We'll spend 5 minutes and you'll be factoring like an old pro, okay? Or you can sit in denial and not know how to factor for a couple of weeks and bomb questions, okay? I choose the first one, the former rather than the latter, and you should as well. I will not ever look at you like you're dumb if you forget how to factor or how to reduce radical, or you're like, you know what, quadratic formula never happened for me. Like I did it, never could do it well. Like it was just bad. I'll be like, cool, we'll go up here and do it. You will learn it way faster now. Your brains are more advanced. You can do stuff way easier now, even from last year. Okay? So promise me that if you don't know how to do something, especially from 10 and 11, that you come and tell me. I don't care. We'll go through it. We'll practice a whole bunch of questions until you can. Okay? If you drown by yourself, like if you're quietly sitting there and you know you don't know how to factor and you don't tell me, I don't know you don't know, and I can't help you. All right? So please, 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 please tell me. Sound like a fan? Sound like a fan. Sound like a fan. Whew. It's going to be the weekend. Let's all just count that as a win. All right. Sound like a plan is what I meant to say. So, cool. Do you know what I don't want you to do? Go to the middle of this question and work the question down from the question. And then you're like, Mrs. Love, I didn't have enough room, so I have to like swoop around the question. No. The craziest thing you do is you take the question, you rewrite it on the left, and then you have so much space. It's a crazy concept. We're going to try it out. So we're going to go n factorial over n minus 2 factorial equals 42, because then we're starting on the far left, and I have all this space to do the question, instead of trying to work it down from where it is in the notes. And you're like, I do that all the time. Don't do that. Please rewrite it on the left. You'll run out of room. All right, so this left-hand side looks a heck of a lot like the top, right? So we're going to actually do this first. We're going to expand this first. But this is actually an equation, not an expression. What's the difference? Yeah. This one has an equal sign. When it has an equal sign, it's an equation. Guess where the equal sign goes? The same place the whole time. It just travels down with the rest of it. Expressions don't have equal signs. They run down the left-hand side because they just equal each other. Do you know what I mean? So you see, so this equal sign is going to just keep running down. This one's going to run on the left. Does that make sense between an expression and an equation? The difference between the two? So we actually put equal signs where they should be? Okay. All right. So we have n factorial. N factorial is the bigger one, because if I put a 6 in here, this would be 6, this would be 4, right? So I'm going to expand the top. So I'm going to get n, and then 1 less is n minus 1. I'm going to restart my computer this week, like tomorrow, and hope for the best if this stops. And then on the bottom, I get n minus 2 factorial. And then because this is an equation and the equal sign's here, I just keep it there, and I put 42. See the difference between an expression and an equation? Very important. We don't want you hung up on where to put an equal sign. We want you hung up on, like, I don't know if it's a 2 or a 4 or something like that, right? Okay, these match, so they go away. Then I'm left with n minus 1, equal sign sits where it is because it's an equation, 42. The next thing I do is expand, right? I'm going to get n squared minus n. That's grade 10. Then I have to do grade 11 to finish this. N squared minus n equals 42. What do we do when we have a squared and a term without a squared? What must we do? We learned it last year. Nope, you can't do that. That's if you have a single. If you have a squared and a number, you can square root and get rid of the squared. Everything's great. When you have a variable with a squared and a variable without one, you have to move everything to one side and set equal to 0 every single time. Everything to one side, set equal to 0. So we're going to get n squared minus n minus 42 equals 0. And when you have it equal to 0, did you know that the fun fact, when you set something equal to 0, when you're solving, you're actually finding the x-intercepts? If you have it equal to 7 or 4 or whatever, you're not actually finding x-intercepts. Once you get it equal to 0 and you solve this, you've just now found the x-intercepts of this quadratic, right? Okay? I didn't hear it. Oh, I didn't. No. But it might, it's just, you know, it's used to eating, and it's not right now. So sad. I feel that. Okay, we have to factor this. N squared minus n minus 42 equals 0. I'm just going to write it here so that you can see it. So when we factor, we say what times what gets me the outside. I always write these out, and people are like, it takes too much work. I don't care. I do it, and I'm a teacher. I go, what times what equals the outside two numbers? So 1 times negative 42. So what times what equals negative 42? And what plus what equals the middle, negative 1. So what are my two numbers that are going to multiply to give me negative 42 and add to give me negative 1? Look up.
Negative 7 and 6.
Negative 7 and 6. And then we double check it to make sure it's right. That's why I always write these out. Because sometimes people will pick 7 and 6 and it's like 3 and 4, or like the 5, 6, and 1, and 3 and 4, 3 and 2, blah, blah, blah. So I double check it. Negative 7 times 6, negative 42. Cool. Negative 7 plus 6, negative 1. Cool. I know I have the right numbers. Sometimes people put the negative sign on the wrong one, right? You'll catch yourself here. Because the multiplication will work, but the addition won't. All right. Because it has a plus 1 in front of it, I can go right to brackets. So I'm going to get n minus 7, n plus 6 equals 0. And then I learned last year that I have to factor these, or set them both equal to 0 separately. N minus 7 equals 0, n plus 6 equals 0. This one, n equals positive 7. This one, n equals negative 6. Now remember, the greatest thing of whenever it says this, algebraically solve, every solving question you should either walk away happy or crying. There should be no in between. You should know you got it right or you did not. Because you can check solving. Right? Solving means tell me what the variable equals. Okay, cool. You now know what the variable equals. When you plug it back into the original, it should match. So you should either be happy or sad. There's no in between. You shouldn't be like, I hope I'm right. You shouldn't hope. It's either right or it's not. So if I plug back in the 7, I'm going to get 7 factorial over 7 minus 2 factorial equals 42. And I get 42 equals 42. So I know 7 is right. I'm happy. I move on. Correct? Now, what if I put in a negative 6 factorial? Can you even do negative factorials? Where does a factorial stop at? 7, 6, 5, 4, 3, 2, 1. It stops at 1. Can I have negatives? If I'm stopping at 1, negatives are past 1, correct? So this can't happen. Now, there is another thing that I learned with all the time of teaching. You guys don't know the difference between no solution and extraneous. No solution means I literally couldn't get a solution. No solution happened in grade 11 whenever you did the quadratic formula, this lovely bad boy here, when you did this quadratic formula, and you got a negative under your square root. And what that meant was, last year when you got no solution, it meant that you had no x-intercepts. Remember the whole thing was above? So no solution means I actually can't factor it. I have to go to my quadratic formula, I plug it in, and I get a negative under the square root. I can't get a solution. It is not possible. No solution. We agree? Extraneous solutions means I got a solution. Did I get a solution? Yes. It was negative 6. I got it. Cool. It was great. It's a great solution. I found it. There it is. But it doesn't work. So when I plug it back in, left side does not equal right side. Okay? And I can't plug this one back in. If I plug negative 6 back into this, I'm going to get negative 6 factorial, which is not a real thing. You can't do it. If you put negative 6 in brackets factorial, it'll just be like, no, not happening. I wish our calculators spoke to us in our words. Like, not today. Like, this is not right. No, stop. Or like, you know, like it would just talk to you in that. Except it's just like error, and you don't know why it's erroring. Which would be like, you put this in wrong, or something like that. Give you hints. You know. So, this is not no solution. Is that a solution? Yes. Does it work? No. So it's extraneous. That's the difference between no solution and extraneous. So this one's good. Yay. This one doesn't work. So I have to reject it. So how do I reject a solution? I put a line through it. I fully reject it. And then I say extraneous. So if this was a multiple choice answer, I would only be picking 7. Correct? Sometimes they ask for the extraneous solution. So then your answer would actually be negative 6. Okay? All right, we're going to flip over to here. Oh, I have so many boards. We're going to finish the rest of this up on Monday, but I want you guys to do 1 and 2 for homework. We're going to still do 3, but we're going to do that on Monday. So you're doing 1 and 2 in your homework book or on loose leaf. That's in a nice spot that you can find it all together and give it to me at the end of the unit so I can check it. Remember the answers are here, but the workbook solutions are actually online if you get stuck. We agree? I've done all the homework questions online. You go there if you're stuck. So you can try 1 and 2.